In previous class, I have told you that dimensions of a physical quantity means the power of the fundamental physical quantities which are present in that quantity. Powers of the fundamental physical quantities present in that quantity. For example, I am giving you another example. Suppose momentum. You say momentum is equal to what? Mass into velocity. That is equal to, we can write mass. This is your displacement by time. So we can write m into displacement means it is a length L by t. That is equal to, we can write m1 L1 t to the power minus 1. So dimensions of momentum are only powers. You write, you give parenthesis, that is 1 comma 1, that minus 1. Dimensions of momentum are 1 1 minus 1 in mass, length and time respectively. This is the dimensions of momentum. Now see, when we write the dimensions of a physical quantity, we use following symbols. You see, for mass, you write M, capital M, length, capital L, time, T, your current, that is your A, ampere, your temperature, Kelvin, K, your luminous intensity, that is your CD, you say capital C, small d, small d, your amount of a substance, you can use small m or you can write mole, mol, mole. Besides those, for angle, we can use theta. For solid angle, we use omega. These are the symbols we can use while we write the dimensions of a physical quantity. Mass, length, time, current, temperature, Kelvin, luminous intensity, CD, amount of a substance, N or mole, angle theta and solid angle omega. Now, we see what is the dimension. Now, then we read, what is dimensional formula? Dimensional formula. The dimensional formula of a physical quantity tells how and which physical quantities are how and which fundamental physical quantities are present in that quantity. Suppose you see, suppose we say density. What is density? Density formula is mass by volume. That is your mass. Volume means length into breadth into height. That is your mass. Length, breadth is also length, height is also length, that is equal to L cube. That is equal to M1 L to the power minus 3. Since T is absent, you write T is equal to 0. Or we can write M1 L to the power minus 3. After writing this, you don't use comma, just to give a square bracket. This is the density, this is, or we can write m to the power 1, L to the power minus 3. So, dimensional formula of a density is, we can write m1 L to the power minus 3 T0, or we can write m1 L to the power minus 3. How means m is in 1 and which means mass. Mass is in 1 times, L is in minus 3 times, and a time is 0 time. So it tells how and which fundamental quantity. This is the dimensional formula of a density, or we can write m1 L to the power minus 3. But the dimensions of density are, we can write only power. You can write, we give parenthesis. Here you use square bracket, but here you use parenthesis, and we write the power, that is equal to 1 minus 3 0. You give comma, here you don't give comma. 1 minus 3 0 in mass, length and time respectively. This is the dimensional formula and this is the dimensions. Remember, in dimensional formula, you write the symbol as well as a power and give square bracket and no use of a comma. But in dimensions, we use only the power of the fundamental physical quantity and we separated by comma and give parenthesis. This is the dimensional formula. What is dimensional equation? The equation in which the name of physical quantity is in LHS and dimensional formula in RHS. So, if we'll ask you what is the dimensional equation of density, you can write, here you write density is equal to, this is the name, the dimensional formula, m1 L to the power minus 3 T0. This is its dimensional equation. It is only its dimensional formula, but 1 minus 3 0 are the dimensions of a density. You remember all this. This is the dimensional equation of a density. While we write, next you see, while we write the dimensions of a physical quantity or a dimensional formula of a physical quantity, the order is, the order of writing dimensions are, first you write mass, length, time. First you write mass, length, time. Then you can write temperature or current. Temperature, current and others. First you write mass. If mass is absent, you can start from length. Length, time, temperature. Order of the writing dimension are first mass, then length, then time, temperature, current, or anything else, but mass, length, time are first you write mass, length and time. Now, these are the dimensions, dimensional formula and the dimensional equation of a physical quantity. Next come here some examples of dimensions. Now I am giving some examples which are essential for writing the all physical quantities. First you see mass, its dimensional formula is, you can write m1 or m, or if you write, you can write m1 L0 T0. This is the mass. Its dimensions are 1 0 0 in mass, length and time respectively. This is its dimensional formula, and we will write the dimensional equation. We write mass is equal to this. Next is your length. Length is what? You can write L1 or L, or we can write M0, L1, T0. Third one is your time. Time is your T1, or we can write T, or M0, L0, T1. Next is your area. Area means length into length, that is equal to L square. You can write it dimensional formula as L square or M0 L square T0. Dimensional formula. Dimensions are 0 to 0. Next, your volume. You remember all this. Volume means length into length into length, that is equal to L cube. That is equal to, you can write dimensional formula is L cube or bracket M0 L cube T0. Next come to your speed. Speed or velocity, we can write distance by time, that is your length by time, or in case of a velocity you write displacement by time, that is equal to L by T, and its dimensional formula is M0 L1 T to the power minus 1, or you can write L1 T to the power minus 1. This is the dimensional formula, but the dimensions are L1 T to the power minus 1 in mass, length and time respectively. After speed, you come to your density. I have already told you, density is your what? Mass by volume. That is, you can write M by L cube. Here, this is your density. That is your M1 L to the power minus 3 or M1 L to the power minus 3 T0. All these are dimensional formula. After density, you come to speed. Speed I have already told you. Velocity also. Your acceleration. Acceleration means your velocity by time. You know the dimensional formula for speed or velocity is L1 T to the power minus 1 by time means T, that is your L1 T to the power minus 2, or we can write M0 L1 T to the power minus 2. Next come to your momentum. Momentum I have already told you. Momentum is your what? Mass into velocity. That is your mass. Dimensional formula of the mass is M, and the velocity is L1 T to the power minus 1. That is your M1 L1 T to the power minus 1. This is the velocity. Next come to your force. Force is your mass into acceleration. You have to remember. First you remember formula, then you can determine dimension. Mass is what? M, and acceleration is M0 L1 T to the power minus 2. That is your M1 M to the power 1, M to the power 0 means M to the power 1, L1 T to the power minus 2. This is the dimensional formula of force. Next come to your work. Work or energy, we can write, this is your force into displacement. This is your force into displacement. What is the dimensional formula of force? M1 L1 T to the power minus 2. Displacement means it is a length. That is your M1 L square T to the power minus 2. This is your dimensional formula of work. M1 L square T to the power minus 2. Next come to your pressure. Pressure, what is the pressure? Pressure is equal to force by area. Force, you know dimensional formula of force. m1 L1 t to the power minus 2. Area means length into breadth, that is your L square, that is equal to m1 L to the power minus 1 t to the power minus 2. This is your pressure. Next come to your moment of inertia. Moment of inertia, that is what is your moment of inertia, that is your mass into distance square. Distance square, that is your m1 into L square, that is your m1 L square t0, or we can write m1 L square t0, m1 L square only. So these are the important physical quantity whose dimensions you know. After that, we determine the dimensions of other physical quantities by knowing the formula of physics, and you know it gradually. You will know it gradually. First, next come to your types of physical quantity. Types of physical quantity. According to dimensional analysis, you know physical quantities are two types: fundamental physical quantities and derived physical quantities. According to dimensional analysis, physical quantities are four types. What are they? One is dimensional variable. Second one is non-dimensional variable. Third one is dimensional constant. The fourth one is non-dimensional constant. According to dimensional analysis, physical quantities are four types. First, you see dimensional variables. What are dimensional variables? These are the physical quantities which have variable magnitude, but they have a dimensions. For example, your force. You see, force, its magnitude is different. That is 10 Newton, 20 Newton, 50 Newton, 60 Newton, like this. And it has a dimension. You know its dimensional formula is m1 L1 t to the power minus 2. Then mass, momentum, work, velocity, acceleration, like this. These are dimensional variable. Second one is your what? Non-dimensional variable. Non-dimensional variables. What are non-dimensional variables? These are the physical quantities which have variable magnitude, but they have no dimensions, because these physical quantities are pure ratio. What are pure ratio? Now those physical quantities are expressed in term of a fraction, but numerator and denominator have same physical quantity. These are non-dimensional variable. Your example is your what? Angle, strain, relative density, your coefficient of friction, like this. These are the physical quantities which have a variable magnitude, but they have no dimension, because these are expressed in term of pure ratio. Pure ratio means the ratio in which both numerator and denominator have same physical quantity. For example, you see, this is your angle. Suppose OAB, this is your angle, this is your L, and this is your theta, and this radius is R. So we can write theta is equal to L by R. You know theta is equal to L by R, this by this. So theta is what is L? L is also a length, R is also a length. So theta is equal to what? L by L, that is equal to L0, or we can write M0, L0, T0. So this is a non-dimensional variable. You know, angle varies from the 10 degree, 60 degree, 20 degree like this, but it has no dimension, and its dimension is 0, 0, 0. Then strain. Strain, what is strain? Strain means change in dimension, change in dimensions by original dimension. Original dimensions. We can say change in length by original length, change in volume by original volume, change in area by original area. So it has also length by length. Its dimension is also what? M0, L0, T0. Next come to your relative density. What is relative density? Relative density is equal to, these are pure ratio. Relative density is equal to what? Density of a substance, density of substance divided by density of water at 4 degrees Celsius. You see, in numerator that is the density and the denominator is the density. So its dimensional formula is M0, L0, T0. Next come to your coefficient of friction. Coefficient of friction, it is also you will read in future. What is the coefficient of friction? Coefficient of friction is equal to what? Applied force by normal reaction. Normal reaction. Reaction is also a force. This is also force by force. Applied force by normal reaction. That is your M0, L0, T0. These are the non-dimensional variable. They have a variable magnitude, but they have no dimensions. Next, third one is your dimensional constants. What is the dimensional constants? Dimensional constants. These are the physical quantities which have a constant magnitude or which have a constant value, and they have a dimensions. They have a constant magnitude and they have a dimensions. They have constant magnitude and also dimensions. For example, you see, this is your body, this is another body, this is your mass, it has mass M1, this is mass M2, and the distance between them is R. So we can say the force between the two bodies according to Newton's universal law of gravitation, F is equal to some, that is your universal gravitational constant G, M1 into M2 by R square. G is called universal gravitational constant, and this is your M1 M2 by R square. This is your force. So this universal gravitational constant, it has a constant magnitude. G has a constant magnitude that is equal to 6.67 into 10 to the power minus 11 SI unit, and we find its dimensions. You know, G M1 into M2 is equal to what? FR square. G is equal to FR square by M1 into M2. Or G is equal to dimensional formula of force is M1 L1 T to the power minus 2. R square means distance, there is a length square. There are two masses. We can write M square. That is equal to, we can write M1 M to the power minus 1 LQ L1 L square LQ T to the power minus 2. You see, it has a constant magnitude, that is 6.67 into 10 to the power minus 11 SI, but it has dimensions. So universal gravitational constant is a dimensional constant. Similarly, others are, we can write universal gas constant, that is your R. Third one is your Planck's constant. Planck's constant. Fourth one is your Boltzmann's constant. Planck's constant you write H. Boltzmann's constant. Boltzmann's constant your K. Similarly, Stephan's constants like this. There are so many dimensional constant, but they have a constant magnitude. You see, universal gravitational constant are, you remember this equation, PV is equal to nRT. What is P? P is pressure, V is volume, N is your number of mole, R is universal gas constant, T is absolute temperature. Here it is the temperature and the number of moles. You see R is equal to 8.31 SI. So we can write, we find the dimension of R. R is equal to PV by NT. What is dimensional formula of pressure? I have already told you. M1 L to the power minus 1 T to the power minus 2. V is your volume. Volume is your NQ. Your number of mole you write N, and the temperature, it is a fundamental quantity. It is also a fundamental physical quantity. That is your K. That is your what? M1 L square T to the power minus 2. First you write mass length time. Then K to the power minus 1, N to the power minus 1. This is the dimensional formula of R. That is your M1 L square T to the power minus 2, K to the power minus 1, and N to the power minus 1 in mass, length, time, temperature, and number of moles or amount of a substance respectively. N is the number of moles. Similarly, I am giving you another example. That is your Planck's constant. Planck's constant. Planck's constant is according to the name of the scientist Max Planck. We know energy is equal to H into F. F means frequency. F is what? Frequency, and H is your what? Planck's constant. Its value is 6.62 into 10 to the power minus 34 joule second. It is constant, always constant. So you see, you can write E is equal to H nu. So we can by HF or HF, you can write H is equal to E by F. What is the dimensional formula of energy? It is equivalent to what? That is your M1 L square T to the power minus 2, and the frequency is your what? 1 by time period, that means 1 by T. That is, you can write M1 L square T to the power minus 2. You take T to upper side, that is your T. That is equal to what? M1 L square T to the power minus 1. These are the dimensions. This is the dimensional formula of Planck's constant. In similar manner, Boltzmann constant has the same dimensional formula like universal gas constant, and we can also determine the dimensional formula for other dimensional constants gradually. Not now, we will determine it gradually. Next come to your non-dimensional constant. Fourth one is non-dimensional constants. You see, these are the physical quantities which are, first point, no dimensions. Second one is constant magnitude. Example is what? Your Joule's constant, Avogadro's number, you know, Avogadro's number, that is 6.023 into 10 to the power 23. It has no dimension, it is a number only. Similarly, another is your Joule's constant, and all pure numbers like 1, 2, 3, and also minus 1, 1 by 2, 3 by 4, pi. Pi means 22 by 7, E means 2.71 ... All these are non-dimensional constants because these are the physical quantities which have no dimension but their magnitude is constant. I am telling you one important thing. You see, there are some physical quantities having same dimension. I write physical quantities having same dimensions. You remember distance, displacement, wavelength, radius, diameter, your wavelength, radius, chord, arc, etc. All these are distances. You can write breadth, height, like this. Distance, displacement, wavelength, radius, diameter, chord, arc, breadth, height, all these have same dimension, that is their dimensional formula is M0, L1, T0. Another point, you remember there are some physical quantities like you say push, pull, force, tension, action, reaction, friction, viscosity, liquid friction. Viscosity means liquid friction. Weight, etc. have same dimensions or same dimensional formula, that is your M1, L1, T to the power minus 2. You remember push means this is also a force. Push, pull, force, tension, action, reaction, friction, viscosity, weight, all these etc. There are so many other things like this. They have same dimensional formula, that is M1, L1, T to the power minus 2. Next come to, there are third point is there. You remember work, energy, power, work, energy, torque, your kinetic energy, potential energy, heat, sound, light, electric energy, all types of energy, magnetic energy, your nuclear energy also, etc. have same dimensions. Dimensions or dimensional formula, that is your M1 L square T to the power minus 2. Remember all this. Similarly, your stress or pressure, it has the same dimension, that is your force by area, that is your M1 L to the power minus 1 T to the power minus 2. These are the some physical quantities which are same dimensions or same dimensional formula. First you like distance, displacement like this is your push, pull, force, tension like this, and this is your work, energy, torque, kinetic energy, potential energy, heat, sound, light. Question will come, what is the dimensional formula of heat? You write that is your M1 L square T to the power minus 2, like etc. Next come to your application of a dimensional analysis. You see, before that I am doing some examples about dimensions. What is the dimensional formula of question? velocity gradient. Velocity gradient, you see, velocity gradient, velocity by length. What is the dimensional formula for velocity? m0 L1 t to the power minus 1 by length. That is your m1 L0 t to the power, sorry, L to the minus 1. This is your L to the power minus 1. This is the dimensional formula of velocity gradient. Next come to your rate of flow. Rate of flow means what? Volume by time. Volume by time means your volume is your what? L cube by time, that is your what? m0 L cube t to the power minus 1. Your frequency. What is your dimensional formula for frequency? Frequency is what? 1 by time period. That means time. 1 by time period, that is your 1 by t, that is your m0 L0 t to the power minus 1. You see, velocity gradient and frequency, they have same dimensional formula. Velocity gradient has dimensional formula, that is your m0 L0 t to the power minus 1, and the frequency has also same dimensional formula, that is m0 L0 t to the power minus 1. So there are many physical quantities like this which we have to, whose dimensions or dimensional formula or a dimensional equation you have to find by yourself. In every class I will do some problems, but I am doing another problem here. First you see charge. What is the dimensional formula for charge? Charge is equal to what? Current into time. Current into time. For current use the symbol A, and the time you t, that is your m0 L0 t1 a1, or we can write its dimensional formula is t1 a1 or ta. You write its dimensional formula for charge. Next come to your electric field. Electric field, your force by charge. Force by charge, you see your force has a dimension m1 L1 t to the power minus 2 by your charge. Charge has the dimension Ta, that is your what? m1 L1 t to the power minus 3 a to the power minus 1. Its dimensional formula of electric field is m1 L1 t to the power minus 3 a to the power minus 1, and its dimensions are 1, 1, minus 3, minus 1 in mass, length and time respectively. In next period, we will read applications of dimensional analysis, which is very interesting. For today, if you like my teaching, please subscribe my channel so that I will be motivated to give you better and better video for today. Thank you, everyone.